We're back, gang!
Yes!
Wah!
Me and Tony were saying like, man, there's gotta be something wrong with us in order to be able to do this thing.
Yeah, for doing this long.
Oh my gosh, bro. Anyways, what is happening, guys? Today we are going to be a little bit talking about why every single first year course that you learn, why does it matter? Especially for a mechanical engineering degree. So like, why does first year matter for mechanical engineering? Why do those courses that you're taking right now as a first year engineer, or why did the first year courses that you take matter for the rest of the mechanical engineering degree? So that is what we're going to be going over today. Okay, so the way that this video will be structured is first I'll go over each of the first year courses that you're probably going to take in your first year of mechanical engineering. And then I'm going to be introducing each of the major subjects that you're going to be taking in mechanical engineering, and then linking those first year courses into each of the major courses that you're taking in Mech E. I might call it Mech Eng, I might call it Mech E, I might call it mechanical engineering. And just a disclaimer for first year courses, I might accidentally name it like Calc 1, I might call it Math 100 according to my university, but I'll try my best to link it to a more general audience just because there are people from all over the world that might see this. Anyways, introducing the first year engineering courses that we are going to be talking about. So we're going to be talking about Calc 1, Calc 2, applied linear algebra, physics. So each of those, for instance, is just going to be your calculus, your algebras, and then your wave physics. So think about kinetics, a little bit of oscillations, those kinds of things. Then chemistry, we're going to be looking a little bit at Chem 1, Chem 2. So just introducing a little bit about the molecular side of things, and then stuff like energy, yada, that kind of stuff. Then we have Eng Comp 100, which is going to be your computer programming for engineers, which might be a little bit of MATLAB or Python, depending on your university. And then you're going to have your engineering foundations, which is going to be your engineering profession and practice course. You might have introductory, and then you might have some engineering mechanics course. You might have a little bit of a project course as well in your first year. And then you might have a dynamics course as well, a statics course. So that's also applying into the mechanics of it. Okay, that is all of the first year courses. But now what we're going to do is we're going to introduce each of the major mechanical engineering. Okay, so first of all is dynamics and mechanics. So what is dynamics and mechanics? So dynamics is going to be stuff like dynamics, rigid body motion, kinematics and kinetics, mechanics, and vibrations. So a bunch of these is essentially stuff moving. That is literally what dynamics and mechanics is. It would be stuff moving or stuff that is not moving. So what are the first year foundations that you're going to be using and applying? So you might be applying a little bit of your physics course, your dynamics course, of course, then your statics course, and then your calculus. So your dynamics course in your first year, you might be talking a little bit about your conservation of energy. You might be talking about your dynamics, so F equals ma. You're going to be sum of forces equals 0, sum of forces equals ma. So all of those things that you're learning in your first year, that all builds on to stuff like mechanics, or maybe it's like gear laws, gear trains, transmissions. It might play a little bit role in how engines work. Maybe it's something like linkages. Anything that is basically moving, that is what dynamics and mechanics is. In first year, so imagine we had, this remote is a good example. So we had this remote that was actually spinning, right? So each part might have a different velocity. So then you're actually going to be studying each point of the remote rather than treating the remote as a single object. Okay, so that is that, and that just brings in a whole other world of interest for dynamics. Then, of course, calculus stuff and all of that. So calculus is really foundational and is a main theme that you're going to see throughout all of mechanical engineering, because it is so applicable to absolutely everything. Calculus is the foundation to any of the equations that you're going to be using. Basically, calculus, differential equations, that is the tool that is used in order to derive all of the equations that you use. Think about F equals ma, or even as simple as the area of a circle. Where did that come from? So that's stuff that you learn in first year, which will be applied later on through dynamics. Okay, so again, first year teaches you forces, motion, free body diagrams, Newton's laws, and then in later years you're going to be looking at more rigid body. So how does the whole thing move, and how can we basically through equations, how can we model the motion through a little bit of complex math?
Yeah, I think it might be a good question to ask is if anybody struggles currently right now with the free body diagram, do you think that would translate into a struggle in mechanical engineering later down the line?
Okay, so mechanical engineering generally, if you do not understand a free body diagram, you're going to be pretty much fine, but you should know how to do a free body diagram. It's actually been a while since I actually did my own free body diagram, so it's not so common in mechanical engineering, but obviously in mechanics, you're going to be seeing it a lot just because you need to understand how forces affect motion. If you're struggling with free body diagrams, it's just a matter of practice. That's literally all I can really say. I think AIs aren't that great with making diagrams just yet,
I don't see it
especially
either.
like technical diagrams. So it's unfortunate that you can't lean on it too much for visualizing free body diagrams, but there's a ton of great YouTube videos out there, YouTube channels. Jeff Hansen is one of the goats. I forget the other one. I think it's Question Solutions. That was my favorite ones for dynamics. Yeah, check out those channels if you're struggling. Anything else from there?
I think that's it for dynamics and mechanics.
So, moving on to the next major subject here that you learn in mechanical engineering is fluids. Basically, all of mechanical engineering. Fluids is anything that is like either a gas, a liquid. So, all of this air, this fluid, the liquid that's going to go through a pipe, that's fluid. So, think about fluid mechanics, aerodynamics, pipe flow. If you ever seen it in my videos, I talk about Bernoulli or talk about stuff like that, is all fluids. So, what is the things that come from first year that apply to fluids? One of the big ones, which is interesting, is it's very heavy in calc and is also for applied linear algebra or linear algebra. In first year, you'll be learning stuff like the cross product, the dot product. I'm not sure if you learn about the gradient, but any of those kinds of things that apply to linear algebra, those things are so important for dynamics, as we said earlier, but for fluids especially, because fluids is just a whole nother level. For example, how do we model a vorticity, or maybe just let's say a toilet that's spinning, the fluid is spinning, right? Math. You will need linear algebra in order to do that, just because it's quite hard without vectors to model that type of flow. But then you can take all of that math, you can put it into a plot, and then it'll show you the vectors and then when you look at the vectors, it'll basically look like a toilet spinning. Like that. That is what a linear algebra is. That's the tool that linear algebra gives you in order to be able to model those types of things. So again, it might seem really weird in first year. You're just like, why am I learning this? But it's really just the foundation and tools that you need in order to simulate these types of complex flows and complex diagrams and plots that are needed in order to visualize nature. With Physics 130, so this might be just your first year physics course, it could apply, it could not. In terms of just basic motion and forces, that's where it might come in. Just because in order to simulate the flows, you'll need some basic understanding of the physics of even just a particle in that flow in order to simulate the whole thing. That is what's happening there. Fluids relies heavily on vector fields, conservation laws, differential equations. This here that we have is that first year gives you the language in order to understand the later courses, which will give you the context of why you're actually building it. So first year gives you the language, later courses give you the context. Okay, anything from there?
I'm thinking that the audience will probably want to know, is there anything you can give them or you can suggest to the audience that can make first year fluids less overwhelming later?
Fluids itself is the lucky thing that you have with fluids is that you can see it so much and it's so applicable to everyday life. Whether you're just turning on a tap or you're driving your car, you can really see why fluid matters. So in fluids, you'll run into a lot of complex equations that are very much not going to be understandable to just look at. But if you really look at the application of it, and then see what pieces of that equation apply to that application, then that's where it becomes fun. And that's where the motivation will lie. So maybe you're a big fan of cars and you really like the aerodynamics of the wing. So then you can see, oh, part of fluids is aerodynamics. So maybe you're looking at the angle of attack of the wing, right? Or maybe you're trying to calculate downforce, you're trying to calculate drag of the car. All those things you learn in fluids. But when you look at the equations itself, they look very complex and you're just like, whoa. But if you look at them and be like, okay, how does this actually apply? Then it's, okay, this equation or this term applies to the drag of the car, or maybe it's the skin friction of the car, where this one applies to the area, the pressure drag from the car. Thinking about it that way and using intuition instead of just looking at equations is, I think, is a really useful thing for fluids.
Yeah, so in other terms, it's just associating what you're learning with real life applications, so you're actually in it and you see the use and its purpose, which makes it easier to learn.
Yes, and that applies to all of engineering. If you feel like you're struggling in engineering, and you're struggling with understanding your equations, I would bring your equations to either just ask it to your professor or TA, and just ask them to look at the equation, look at each of the terms, and explain what that term actually does in terms of real life. What is its significance in real life? Maybe there's a cos in there which causes it to oscillate. What does that oscillation actually mean? Is it a spring that's dying, that's decaying, right? Or like what does that actually mean? It's more than just a cos.
That's right.
What does it actually mean? Yeah. So I think that's a really big thing.
I think that's it for fluids. Yeah, because you talked on some of the other things I had, so that's just it for fluids.
Okay. The next one here we have is thermodynamics and heat transfer, which is one of my favorite ones, just because heat transfer is really cool to see and visualize. The courses that you might take is just thermodynamics, heat transfers, energy systems. So those types of courses and thermodynamics can be just anything from like engines, or it can be turbine cycles.
So cool.
Yeah. The thermodynamics is like a whole thing, and then heat transfer is just maybe you're trying to model the temperature through a wall. Like, how do you model that temperature, right? Now, this is where it gets interesting. So for your first year foundations, you might be looking a little bit at your first year chemistry, your physics course, and then your calculus course again. Calculus, as I said before, is the basic language for engineering. And it could be a podcast in itself. Is that mathematicians make the equations. Physicists actually take those equations and try to apply them to their problems. And then engineers will take the things that physicists figure out in terms of the equations and how they apply, and then try to apply them in real life to solve problems and to try to innovate. So that is the workflow or the flow of the equation through those three disciplines. And the reason why I'm saying that is because calculus is, again, you're seeing how calculus is the foundation that is needed, the language that is needed in order to pass it down to the engineer. So we're going to be looking at chemistry. So when you think chemistry, we're thinking about maybe it's something like enthalpy or heat. That is things that you learn in chemistry. Like, for example, I'm taking a combustion engine course right now, and we're looking at calorific values, right? That is not something that I've seen since like maybe high school or first year chemistry, or just enthalpy and how the combustion process, how enthalpy changes throughout the combustion process, and how those reactions work, and how those reactions can create carbon monoxide, or it's too lean, it's too rich, like those types of things. So that's where thermodynamics can come in terms of chemistry, from chemistry. For heat transfer itself, so this heat transfer is an interesting one because it is very reliant on differential equations. But when I think about heat transfer, I think about one of the main problems that you learn is how to look at a wall, or look at the cross section of a wall, and oh damn, wait, what was that?
Hold on, podcast break.
Oh, did it run out of? Again, so yes, I think one of the big themes here is you really do need calculus in order to succeed at that. Okay, but yeah, so thermodynamics here, it asks, how do we turn heat into work? Or so that is the big thing about thermodynamics.
The audience might have a question is, when you're going through thermodynamics, it must feel pretty abstract at the beginning. So when does it start to make sense?
It doesn't. When it depends on the person. Honestly, there are some concepts that I only started understanding now.
In your fifth year,
In my fifth year, just because they were just like thrown out at times. Like for example, enthalpy.
okay.
Like okay. Enthalpy is not.
We're back.
But okay, I'll go back to heat transfer. Now, heat transfer is an interesting one because one of the main problems that you'll see in heat transfer is essentially how does heat flow from one medium to another, and how can heat flow? So is it radiation, is it conduction, is it convection? So there's different types of problems that you can see in
Yes.
heat transfer, and that is moving towards fluids as well. Just because if there is fluid flow across, maybe it's like a boiling plate or something, how does it carry heat and through convection? So that's like some of the problems that you might see in heat transfer. And in order to understand that from first year perspective, that again comes a little bit from chemistry, but it really is dependent on the math of it again, because through fluids and through heat transfer that you'll see is that you're trying to use vectors,
Right.
or yeah, I think you can say vectors. You're trying to use vectors to be able to visualize how nature works, right? Or you're trying to use graphs or plots through a temperature, like a temperature gradient through a wall. So maybe it has temperature point here, temperature point here, and then how does it go through the wall? Maybe
Yes.
it's just linear, and it just. In order to understand those types of things, you need calculus again. So yes, I think one of the big themes here is you really do need calculus in order to succeed in engineering. But yeah, so thermodynamics here, it asks, how do we turn heat into work or remove it? So that is the big thing about thermodynamics.
Yeah.
Term of chemistry,
What in what
when you
context
learn
does
about
that make sense to me?
or whatever it might be, like your first year of chemistry.
Perfect. I think that's it
anything
for
there?
thermodynamics and heat. When you're going through thermodynamics, it must feel pretty abstract at the beginning. Materials.
Now we got materials. It doesn't. When it depends on the person, honestly, to be honest, there are some concepts that I only started understanding now in my fifth year, just because they were just like thrown out at times. Like for example, enthalpy. Enthalpy is not something. Enthalpy equals the internal energy of the chemicals or whatever plus the pressure times volume. That term,
I feel like if I was in
internal
Eng,
energy
I'd
might
probably
be,
be picking
but
materials.
pressure to volume is not too much. But pressure times volume is essentially work
biggest
equals
big brain
force
people
times
there, though.
distance. The force
Gotta be brain.
is pressure times area, because stress equals force times area, or pressure equals force over area. So then pressure times area would equal your force. PAX, pressure, and area times distance equals volume. So you have PV. So it's a work. All that is just it's work. So enthalpy equals your internal energy plus some work that it's got to do. Does it break during the manufacturing process? Like that is not something that I understood until just recently, because like enthalpy is not something that is very. It's not something that you can sit with very long with, but it does make sense when it makes sense. So it really depends on the person. I'm sure people understood enthalpy in like their second year, first year, but for me, when things were just so busy and you just keep on learning content, it's like things can just pass by and then you're just like, oh, I learned that, but what did that even mean? Yeah.
Ooh, voice
Exactly.
crack.
Yeah. That's what I
From the audience, if the person right
Okay.
now is in first year, dislikes chemistry, should they be
try to
worried
speed it up a
about
little bit
materials
here, hey?
later?
Now we got materials engineering. Materials engineering is actually one of my favorite courses in mechanical, just because you get to understand on a more microscopic, or I guess nano scale, why the materials that you're using for anything that you make matter, and why they have the properties that they do. So why is something brittle? Why is something ductile? Why does something have a certain boiling point or melting point? What are the phases of that? What a lot of material engineers might say is that materials engineering is what high school students would think is chemical engineering. Chemical engineering is very much what I just talked about earlier was like the thermodynamics. You might experience more of that in chemical engineering, whereas in materials you might experience more like the phases and stuff, which is experienced more in your high school chemistry.
That's fair.
Yeah, me too. I think
I'm
when
gonna
I get
ask
asked the
you one on
question, other
because I like
discipline what
materials so
I've
much.
chosen. Materials
So,
because I
what
really like
first year
chemistry,
concepts help
that
you
part of chemistry,
understand why
and why I like
materials fail?
materials engineering, my materials engineering courses, or biomedical, just because biomedical is cool. But again, for materials engineering, as I mentioned, that's going to be taking in your chemistry. So think about phases, phase transformation, and materials talks a little bit about failure analysis. How do things break? How do they break when they're brittle or ductile? So maybe those types of things you might learn in your first year. So understanding material properties a little bit, getting that introduction. And then manufacturing processes. How do you actually make this material do what you want so that it gets into the shape that you want it to be for whatever part you're making, right?
Yeah.
That's what you'll learn later on. And you need to understand the material
Exactly.
properties so
Yeah.
that your thing doesn't break during the manufacturing process.
Ooh.
That's foundational from your first year chemistry. High level chemistry is more atomic behavior from your first year. Chemistry is where you have atomic behavior. Mechanics is something that's also there in terms of manufacturing processes, which you'll understand, and it's like forces and stress. And putting those two together is really where a part of materials engineering really lies. Okay. These are where
from the audience,
that's when you have that your first
the person right now is in first year, dislikes chemistry. Should they be worried about materials later?
just a course where they give you advice on the engineering. I don't know if you should be necessarily worried about it, just because everyone seems to just go through materials, and you don't have to love something in order to get through it, especially in engineering. Like unfortunately, we can't pick and choose every single course that we take, but you'll find that it is very foundational, and you'll have to understand some of the chemistry in order to understand why things happen. And chemistry is important for a bunch of mechanical engineering. Again, as I mentioned, thermodynamics, it can be something like that, the water turning to vapor, right? Or what does this material look like under a microscope, and why does it look like that? You'll need a little bit of chemistry for that. So,
Okay. I'm gonna ask
Okay.
because I like materials so much.
yeah.
So, what first year concepts help you understand why materials?
Through those first year courses. Ooh, I think atomic structures might help with understanding that, just because I don't remember if you talk about BCC, FCC, if that stuff is in first year engineering, but atomic structures is part of. Why does a chemical compound? What is the shape of most basic way I can describe it is you have a chemical compound. What is its shape, and how does it? And that's something that you might learn in first year, or just chemical compounds in general. And how does that chemical compound or shape affect the material properties of a material? Like that is what it really comes down to. If you're ever curious about what. Okay, cool. Now we got my favorite one here: design and project courses. Okay, so the later mechanical engineering courses you might take is like capstone design, team-based projects, and like those are the big ones that you're going to be doing. Which like every other semester you might do it, or I don't know what you guys might do, but these ones are always incredible challenges that you'll face, especially because you're in a team and you're given a problem in the beginning by a professor, and you have to spend the whole semester or 2 semesters trying to solve that problem, right? Or it might even be from a client. But what are the first year foundations from that? So that's when you have that your first year team-based course. You might have your first year project course, and then you might have your Eng 100 we have, which is just a course where they give you advice on the practice of engineering.
Enough
And
time, eh?
you might be something like how to work in a team, and how to communicate. And like I understand that sounds boring.
Oh damn!
And-
Okay.
but it's incredibly important
jump in.
because
We jump
in
in.
engineering you're not working alone.
Goodness
right?
gracious.
You have to be as efficient as you can as a
Whoa.
team. Then you have to understand the
It
team
like
dynamics. with
the hate
understanding
came
things like
over to me and I gotta
communication,
rub my eyes out and be like,
understanding,
whoa.
social skills, those types of things, and team dynamics. Those are things that you have to understand.
Dang.
And, even us or people from your courses, like professors, they might teach that through those types of courses. So yeah, it seems boring. It seems very easy to say, like communication, but it is very important for engineering, and it is probably the one of the top, maybe my top 3 skills that are most important for succeeding as an engineer. But through those first year courses, you might do stuff like try to do a little bit of engineering drawing. Like it might be very basic because you don't have those CAD skills yet, maybe most likely. But going through that design process is a big one. And understanding how do we go from an idea to evaluating that idea to actually
You can see the
doing the
struggle
calculations
on
for
his
that
face.
idea, and then carrying that out, whether it be through prototyping, manufacturing, and then actually getting it to market or actually making it a real project to be constructed. So that is where it really comes down. And then, of course, team dynamics is an important one that you'll have to understand from your first year engineering courses.
We have a
to,
whole skit on that.
succeed in those project courses in mechanical engineering. If you're ever curious about what I had to do for my design courses through mechanical engineering, my second year course, we had to just basically make a robot in a team of 6, I believe, or 5 or 6. And then we actually had to design it through SolidWorks. We had to actually create it, and then it actually had to perform in it was like on a design day, or it was like a competition day, basically. A lot of fun. Then through my third and fourth year, that's where it becomes more design heavy, where you might not actually be prototyping or actually building anything, but the design part
hard.
and the reports can get a lot of work because now you're getting deep into trying to apply everything that you've learned throughout your 3 or 4 years at that point to actually creating a project. Yeah, that is the design course. I think we can move on to mechanical measurements just so we have time. Now, moving on is mechanical measurements, which is one course that I hate.
Damn, okay, we jump it.
Through English.
Whoa. Like the hate came over to me and I gotta rub my eyes out and be like, oh.
Yeah. I'm sorry. I know it's important. It's just. What is mechanical measurements? Mechanical measurements is basically how do we measure anything in mechanical engineering, whether it be a length, a width, or it's a depth, or it's a pressure, it's a velocity, whatever it may
That's
be,
rough.
something that we need to measure. How do we actually measure it? Now, it can be very complex and it can be interesting too, because you need a lot of devices, electronics. There's some electronics that plays into trying to get that down, because you're going from something that is flowing in nature and you have to somehow you have to somehow process that information and then have it show up on a screen. Like, bro, how do you do that? How do you do that? Like,
You can see the struggle on his face.
but the part where it really sucks is when you have to measure a standardized
Talk about easy
cube
life?
50 times
Damn.
between 5 people, because you have to calculate the error and uncertainty in the measurement. Yeah. Anyways, I'm sorry for crashing out. But what are the first year courses that you might need for that one? You might have a lot is coming from your lab courses in your first year, and that might
Comment
stem
section.
from chemistry or physics. Most likely it's some physics or dynamics course, where you're going to have to do multiple iterations of the same experiment, and then understanding all the data, taking all that data, finding your result, finding your uncertainty, all of that stuff, everything that plays a little bit into statistics as well, which is something that you'll learn in your later years in engineering, and it's maybe a little bit in your first year. Yeah. Also, one thing that is very important for these types of mechanical measurements courses is the report writing.
It's there.
You might have seen that one video of me
Yes.
with the screen in the back, and it says one page essay with 100 words, and I'm crashing out, and then it shows up a derivative, and then I start celebrating. That is because I hate report writing, and a lot of engineers feel the same.
Gotta know math.
through English, and that's stemming a little bit from report writing, right? So how do we actually create professional documents in engineering, and how do we make them so that they're professional enough because they are actually treated as legal documents? How do you present those types of things? You'll be learning in that first year English class. Don't like it. Don't really like it. The thing that we have written down here is how wrong is this measurement and why?
On math?
That is the course.
That's rough. No, it's like just the base. It's supposed to be the base language.
Okay. So
One of
something
the
that is numerical
how
methods
students should
and
think about
computing.
math is
So
disconnected
this one is
from
interesting
engineering.
because numerical methods gives you a way of
can't
doing math
be.
without having to do math. It lets the
It's
raw
without it, you
dog
can't
doing a
so
bunch of calculations until it to a solution. So it's basically iterating until it
shouldn't
comes to
do
a solution,
engineering, yeah.
and then we have a solution. Damn, saying that. I
Join
didn't
me in
have-
the
I
science
didn't even need to do
department.
derivative. Okay. Now numerical methods in computing is really based on your first year coding course and a little bit of that math 100 and math 101. I think part of it might be like Taylor series. So like something like that because you have to work with approximations. And I believe Taylor series works a little bit with approximations. Correct me if I'm incorrect with that.
Like the one you
But yeah, how do we take data and how do we approximate it? And Taylor series does that. Taylor series is one of the things that you might be taking in your methods. The computer figures it out, right? And because it's with the computer, you might have to do a little bit of coding, which is for where your first year MATLAB course might come through, or your maths might come through. But yeah, you'll be fine. That's electrical engineering. It's there, but it's not there. We also have math, which is a big thing in mechanical engineering because it's literally everywhere, bro. Math is literally everywhere. To me, yeah. In that first year, you'll be doing obviously your Calc 1, Calc 2, and your linear algebra, which might be 3 courses that you might do. Again, as we said throughout the video, math is the language or the theme that you have to understand in order to actually carry out all of the calculations that you need for engineering. Because engineering is basically using math in order to predict what's going to happen in real life, and then using those predictions in order to innovate and create solutions to problems. That is what engineering.
We're gonna make a skit on electrical engineering.
Yeah, that's really all I can say there. Here we have mechanical engineers don't become electrical engineers, but they have to understand the systems that include.
One of the questions that we hold is
discipline.
how students should think about math if it feels disconnected from engineering.
Subsystems work together
Um,
in order to create a good design.
it can't be.
That's one of the reasons why you're learning electrical.
Without it, you can't do engineering.
Yeah. If you don't like math and you hate math, you probably shouldn't be in engineering.
Yeah, I don't think so.
I'm not gonna lie. Now we have very last major subject that we have, which is statistics. Now we get to understand a little bit about the multidisciplinariness of mechanical engineering, if that's even a word. Where you learn a little bit about electrical engineering, EE. This one is a little bit fun because you get to actually experience circuit analysis, and understanding. You even get to use a breadboard and do experiments with breadboards and stuff like that. Yeah, a breadboard. You got me there. But yeah, you get to play a little bit with your breadboard, and especially for those that really have a passion for and hobby for stuff like electronics and Arduino, stuff like that, you're probably going to excel really fast with those labs. Because to me, I did a little bit of that in my first year through club experience, and then when the labs came, I'm like, oh, I can just make this really quick, and then the lab was just like, but yeah, that's electrical engineering. It's just very introductory that you'll learn electrical engineering, but that comes in with physics 130, which you might experience a little bit of wave physics in electrical, AC, like right, or like alternating current, like a sine wave to me. Looks like so. That's part of electrical engineering, and you might do some stuff with a little bit of coding. You might not. I don't think I really did much coding in my electrical engineering course, but yeah, it's basically doing some very introductory circuit analysis and understanding on a very high level what is, how does electricity work. You're not gonna get to do electrical engineering. So, yeah. Here we have mechanical engineers don't become electrical engineers, but they have to understand the systems that include electronics. And the reason why this is important, again, is because mechanical engineering is such a multidisciplinary discipline, and you need to understand how these components and subsystems work together in order to create a good design in mechanical engineering, which might seem like, why the heck am I do that? But yeah, that's why. Anything there? Very boring. Numerical methods of computing. Now we have the very last major subject, which is statistics and probability, which you might be taking maybe in your second year or your later years in mechanical engineering. And this really goes down to experimental analysis, so taking a bunch of data and trying to calculate what's your mean, what's your p-value, what's all that kind of stuff in my internships, because we had to do a little bit of QC/QA work, which is quality assurance, quality control, which is basically making sure that things that you are using for your designs are actually up to standard and are up to spec, so that they can be used. And that's where a little bit of the statistics come in. It's not going to be first year foundations, so your first year, from your first year courses, but it's not really calculus heavy. There might be a little bit of calculus baked into there, but it really might come down to your labs in first year calculus or first year engineering. So, I guess that is what we had for the major ones. But just to briefly go over it, if we go back to the core mechanical engineering domains, dynamics mechanics is very much reliant on your dynamics, your first year dynamics, which basically takes something very simple like a particle, and then we make it more complex by looking at the whole body later. We need stuff like cross products, dot products, vectors, and we need that in order to simulate fluid flow. For thermodynamics and heat transfer, you're going to be looking at combustion engines and other types of thermodynamic cycles and heat transfer through a wall, stuff like that. And that comes down from chemistry and those types of courses. Materials engineering, again, is also a bunch of chemistry. It's what you would think chemical engineering is when you're not in chemical engineering. It's actually materials. The design and project courses, those are team courses. You'll need to understand how to work together as a team, how to actually go through a design process, how to communicate, all those things in your first year so that you can actually carry it on in your later years. Through your mechanical measurements, that's when you repeat the same thing a bunch of times and try to figure out what's the uncertainty. Very boring, in my opinion. Numerical methods of computing, that's just letting the computer do the work for your graphs and stuff like that. That's what that is. Your maths, you have calculus, linear algebra, differential equations, you might have a little bit. And that's obviously the language that you'll need for it.
Hopefully we answered that question.
Electrical engineering, you might learn a little bit. You might learn a little bit maybe in your labs or a calculus. That's the foundation that you'll need in order to understand electrical engineering. Statistics and probability, again, comes down from your labs mostly. And then one final one that we do have, which we didn't add in specifically as a major one, is solid mechanics, which is mechanics, which is I baked into the dynamics, but it is worth mentioning just because that looks at the civil side of mechanical engineering, where you're looking at stress, strain, applying loads onto beams or concrete columns. Concrete! And then that's taking a little bit from your materials as well, because you have to understand when those things will actually break. And yeah, like deformation, those types of things. And that comes down from your first year statics course, mostly. And from first year statics, you might look at trusses, beams, free body diagrams, shear force diagrams, bending moment diagrams. Those types of things come in the first year, and then you'll learn more about them in your later years. Oh, I really like this one sentence, which is a great way to close out this video, which is first year gives you the language and later courses give you the context as to why. So if you're ever wondering why the heck am I using this stuff, it's just a matter of waiting a few more years, a few more courses to see why it really matters. So be patient, and that's really a big one. Yeah. One final note that I'll leave you here with is first year courses are designed to try to break you, perhaps. They are designed to be challenging because being in engineering requires you to really challenge yourself and put yourself in a critical thinking mode and understand what are all the things that need to be considered when you're trying to create a design to a problem. It's very much is demanding, but you got it. Yeah. There's always going to be work. There's always going to be work to do. Anyways, that is so like, why does first year matter for mechanical engineering? Thank you all for watching.
Hopefully we answered that question.
Yeah. I hope that helps.
Thank you.
Okay. Peace out, guys. If you're in first year engineering, by the way, check out the free guide to succeed in first year engineering. We'll leave a link in the description for that. It's going to be the first few chapters of my guide to succeed in first year engineering. And then you can also get the whole edition if you really want for all of the advice that I would give myself as a first year engineering student. But yeah, that is basically all I got. Thank y'all so much.
Bye-bye.
Peace out, guys.